Good afternoon, everyone. So let's continue our discussion from the last class. In the last class, we looked at this program cube1.c. You can see here. In cube1, excuse me. Yeah, so what this program does is on line 6, we are declaring three variables, length, breadth, and height. And we are initializing these three variables with the length, breadth, and height of the cube. And then on line 7, we are declaring a variable called volume, and we are declaring its type as integer. And on line 14, we are computing the volume of the cube. The statements on line 10, 11, and 12, they are commented. They are commented using C++ style comments, where we use two forward slashes to comment the line. So the comment ends within that line. Unlike in the C-style comments, where it is possible to comment multiple lines using forward slash and star followed by backward slash or forward slash actually. So just to say, this is the C-style comments, and this is the C++ style comments. And C++ style comments, they are supported in C99 standard. C99 standard. And here we are printing the volume. On line 16, we are printing the dimensions of the cube in a specific format. And on line 17, we are printing the volume of the cube. And on line 21, we are printing the perimeter of the cube. So there is a question in the second printf statement, can we skip the %d or is it part of the syntax? So we cannot skip %d. We cannot skip %d. So if you want to, this is a placeholder or a format specifier for how to print volume. Volume is a value. We want to print volume, and this %d tells how we should be printing the volume. Good. Are you all with me on this program? Any questions on this program? So there is a question on any rules for setting variable names. So I will get to those rules a bit later in today's lecture itself.
Sir, I noticed something on, am I audible?
Yes.
So on line number 14, we have written volume equals length times breadth times height, right? Okay. So if we are just assigning values, we use one equal to sign. But in this case, we are computing the value. So shouldn't it be equal to like two signs? Because
no. So on the right hand side of the equal to, you have an expression which is taking the product of three values. And on the left hand side, we have the variable to which the computed value should be assigned.
Okay, sir. Thank you, sir.
So one thing about this program, one thing not so interesting about this program is, if you run this program, it can only compute the volume and perimeter of a cube whose dimensions are 3 by 5 by 2, which is not so interesting. So every time you run the program, you just print the volume of the same cube and the perimeter of the same cube. It's not interesting. You might as well use a calculator to get this job done. So here you have a program. So this is your program, cube1.c. So it has only output. There is no input to this program. There is no input which is consumed from the user in this program. So we would now like to modify this program so that it takes length, breadth, and height as input. And that's what the program cube2.c does. We'll write the program cube2.c, which takes input, the length, breadth, and height, and then it computes the volume and perimeter and prints it onto the screen. Okay, so this is your cube2.c program. So here again on it has, if you see any program, so it has one function main. So there is a on line 2 you have an you are including this file stdio.h, and on line 6 you are declaring 3 variables, length, breadth, and height. On line 7 you are declaring the variable volume. We are declaring all these variables as integers. And on line 9 we are telling the we print to the user that enter the length, and so this is the statement for consuming input, reading input provided by the user. This is called as a scanf statement. So similar to printf statements, scanf statement takes it has the first parameter to the scanf statement is a string. This is this tells the %d here. It tells that the user would like to enter a integer value as input, and then whatever the integer value that is entered by the user, it will be stored in the variable length. It will be stored in the memory location associated with the variable length. You can see similarly in line 12, we are reading an integer input from the user, and the associated value will be stored in the memory associated with the variable breadth. The same is the case on line 14, and it is and it stores the height of the cube in the variable height. On line 16 we compute the volume, and on line 18 we are printing the dimensions of the cube, and on line 19 we are printing the volume, that is volume of the cube.
Sir, one question.
Yes.
Am I audible?
Yeah, you are audible. Yeah.
So in case of scanf, does the %d also serve as a placeholder again?
Yeah, that's true.
But it's only for like just giving the, it's just, but last time you said it's only used to format the order in which.
No, it's not like that. So the same thing, it serves a different purpose. The %d in scanf, it tells that we are anticipating an integer input.
Hello.
Yeah.
Am I audible?
Yes, yes.
Yeah. So, sir, hypothetically, in a scanf statement, if inside the quotes I used say 3 different placeholders, and correspondingly I put and length and breadth and height, is that legal? And will it work?
Yeah, it will work. It will work.
And sir, do I have to put a space between the placeholders?
You have to keep a space between them. We will get into those details in tomorrow morning's class. Tomorrow morning, we will take a look into printf and scanf in a little bit more detail. So for the time being, just assume, take this, at least this much understanding you can have, that on line 10, line 12, line 14, at each of these lines, the system takes an integer, and whatever the integer from the keyboard and whatever the integer that is provided, it will be stored in the corresponding variables given in the scanf statement.
Excuse me, sir.
Yes.
Sir, what is the use of %d here?
%d tells that the input, expected input, is an integer.
Okay.
It's
And
not a
the-
value like 2.3 or 4.7. It's not like that. We are
And
expecting
for decimals and float
we
point,
use a different, if you are expecting a floating point number as input, that is decimal number 2.7 or 4.8, then we use a different format specifier.
and the and is for address, right?
And I will tell you what the TAN will do a bit later. You are right, but I will explain it in detail later.
Is percentage D the only placeholder, or are there other kinds as well?
Sorry?
Is percentage D the only placeholder, or are there other kinds as well?
No, there are many. There are many. You will get to know them. Yeah.
Hello, sir.
Let's run this program first and see what is happening. Oh. So if you see GCC, this is cube.c minus O cube2. And if you enter the length as 12, breadth as 2, and height as 3.
So I have a question here.
And the volume turns out to be 72.
So I have a question.
Yes.
So instead of 12, like if I entered some decimal value like 12.3, 12.5, then would it show an error, or would it?
So we will deal with those things. You should try out and see what happens. I will give an answer to those questions. Like what if you don't give the appropriate input? I will answer those questions in tomorrow's lecture. All right. Good question. But
Okay,
for the
sir.
time being, let's assume the user is good and he gives integers as input. What happens if an incorrect input is given, or an input which doesn't match the format specified, the type, whatever the type that is specified, if it doesn't match, what will happen, we will see in tomorrow's class. For the time being, scanf helps us in reading input from the keyboard. And the %d tells that the expected input is an integer.
Hello, sir.
Yes. Yeah.
Can you hear me, sir?
Yes, yes.
Sir, how long can the number be, the input number that we give? Is there any limit?
There is a limit. Again, we will get to that after few lectures.
Okay, thank you, sir.
Excuse me, sir.
Yes.
I had a question about placeholders that I wanted to clarify. You said
Okay.
that there were different placeholders for different data types. So if I wanted to use one in a command like printf, would I also have to use a different placeholder? Like say if I wanted to print a string or an integer from a variable.
Yes, yes. So that's what all questions on printf and scanf, I request you to hold on to them. Tomorrow morning we will look at printf and scanf in greater detail.
Okay, thanks, sir.
Okay. But at least this much, are you with me? Like, do you understand this program?
Yes.
Sir,
Yes.
am I audible?
Yeah, yeah.
Sir, can you open the terminal for 1 second?
Okay.
Sir, in the statement, like is it enough to just write GCC cube2.c, or do you have to write that minus o dot cube2?
It's not necessary. It is, if you just say GCC cube2.c, then the executable will be present in a.out file. And if you want to execute your program, you have to use a.out to execute.
So what difference does it make if you use minus o dot cube2?
It writes the executable in a different file. Whatever, instead of writing it in a.out, it writes in a file cube2. That's all the difference.
Okay, sir.
All right. So let's see now. Yeah, I want to explain this printf and scanf in a bit more detail. So let's look at, so what happens, let's say, if you see this printf statement, this printf statement is passed what is called as a string literal. This is called as a string literal. This is called as a string literal. And so what this string literal means in the memory, this is your RAM. So let's say for the sake of simplicity, instead of this whole big string, we have a simple string hello. What happens is, this is not, okay, this is your RAM. And you know your RAM is a sequence of bytes. Let's say the string literal is hello. You are printing hello onto the screen. So somewhere in the RAM, so this hello is stored as a sequence of bytes. So H is allocated 1 byte and E is encoded using 1 byte. L is encoded using another byte and another L. So like this, your hello string is stored in the memory as a sequence of 5 plus 1, 6 bytes. And there is a last byte which every string terminates with. This is called as a null character. And you know, like every byte in the memory, it has an address. Let's say the address of hello, this H, the first character is 100. Then E is present at the byte 101, L is present at the byte 102, so on and so forth. So what happens is, your printf, it's a function. Okay, this is a function. If you think of it as a black box, because you don't know exactly how printf is designed. So this printf, you pass this the address of this, the base address of this string to printf. So you pass 100 as the base address of the string hello as to printf. And then printf uses that base address to know what is the string that is being passed, and it knows where the string will end, because at the end of the string there is a special character called as a null character which tells that the string has terminated. So let's say you have some statement like this. Okay, so you have something like instead of just printf, you have printf hello. Yes, the null character occupies space. You have something like printf hello %d, and you are printing some random value, some value. Then what happens is, the way, so it will be now %d. This is the whole string. Followed by that, there will be a null character. So here there will be a null character. This is called a string terminator. So this is the base address of this whole string will be passed to printf. And not only that, this val is, remember, let's say val is allocated memory somewhere here. Okay, it is allocated memory somewhere here. And let's say the address of val is 50. This memory location corresponds to val. And val contains the value 4, for example. Then what happens is, printf is passed 2 parameters. One parameter is 100, which indicates, and that is the base address of the string. And the second parameter is 4, which is the value, or which is the contents of the memory location associated with val. So here, if you see this picture, printf will take 2 inputs. One is 100, the other is 4, where 4 is the value associated with the second parameter here, that is the variable val. So there is a question. So does the semicolon symbol, in code represents the null character in RAM? Not at all. There is no relationship between the semicolon in your program and null character in the RAM. No, not at all.
Excuse me, sir.
Yes.
Sir, so when we put the %d,
Yeah.
sir, the value of the integer is not stored in that location. Only it's an instruction to go to the location where the integer is stored and print that.
Yeah, exactly. So when printf sees 100, it gets two parameters. One is 100 and other is 4. Printf looks at location 100, it sees h, it prints h. It goes to next location 101 and it sees e, it prints e. Like that it keeps going, and then once it hits % and d, then it knows that it has to look at its second parameter 4, and it prints 4 on the screen. Instead of printing %d on the screen, it prints the other parameter val, that is 4, that is being passed onto the screen.
Okay, sir.
Does it make sense? Are you all with me here on how printf works? Printf starts from h, it keeps printing one character at a time. When it hits %d, what it does is it doesn't print %d, it goes and looks at the next thing, whatever the next parameter that is being passed, it turns out to be 4, and it prints 4 in the place of %d. Great. So now let's see how scanf works. So scanf also, so what happens is similar to printf. Let's take this simple statement on line number 10. So something very similar happens for scanf also. So let's say scanf, there is this string, this whole %d, it is a string literal. So %d, let's say this is the base address is 100. And then after that, somewhere down the lane, you have at memory location, let's say 150, the variable, this location is allocated to the variable length. So now what scanf, if you look at the scanf function, so scanf function, this is scanf function. The difference between printf and scanf is this. It's so now scanf takes two values. One is 100, that is the base address of the string %d. The base address of the string %d is 100, that will be provided. And the next, then second thing that it takes is the base address of the address of the variable length. The address of the variable length is obtained by using this ampersand operator. When we say ampersand length, then that means it gives the address of the variable length. So what happens is this 150, the address of the variable 150 will be passed here. And what scanf does is it reads the input from the keyboard, and then it goes to the memory location associated with so actually what scanf does is it starts from the memory location 100, it looks at % and it looks at d, then it knows that it is anticipating an integer value from the keyboard. And once the user enters the integer value, then what happens is whatever the integer value that is read from the keyboard, it goes and places it in the memory location associated with length or with the address 150. So let's say the user entered 4. So 4 will be stored in the memory location associated with the address 150. And we know that 150 is nothing but the address associated with the variable length. And then actually, even after this %d, there will be a null character indicating that the string for scanf has that is being passed to scanf is stopped. This is null character after %d.
Sir.
So I will take your question. I saw your question on the chat box, but before I take that question, I want you to know whether you understood how scanf works. So scanf needs to know the address of the variable because the value that is read, it wants to go and place it at that particular address. So because of that, we want to pass the address of the variable length to scanf. But on the contrary, if you use printf, okay, let's say you want to do printf, this is the question that is being asked, %d length. In order to print the value of the length onto the screen, printf doesn't need to know the address of the variable length. It needs to know the value that is present in the variable length. So that is the reason, let's say length contains 4. So what happens is you just, so 4 will be passed as the second parameter to printf. So if you use, so someone mentioned, so if you use instead of length, if you use ampersand length, then what happens is the address that is associated with the length will be printed on the screen. Does it answer this question? If you use the % length, then the address that is associated with length will be printed on the screen. Are you all with me on scanf and printf?
So I had this clarification. So when we declare variables, that is like int length, breadth, height, we actually assign memory addresses to these variables, right?
Yes.
Okay, thank you, sir.
So there is a question, what if we use length instead of ampersand length in scanf? So you should try it. Then what happens is, let's say the length contains 4, then scanf tries to go and update the memory location 4. All right, I think we are all good. So just want to see how you're all doing. You're all with me so far on scanf, printf, on what parameters go to scanf and so if you understood this, then many ideas in C, they become easy. So let's get going then. If you're all doing good, then let's go to another program. So this is a program. So yeah, what this program does is we will take, there's a certain quantity of rice you want to is available. It could be some, let's say some 800 kgs of rice is available. And we want to pack this 800 kgs of rice into different sacks. And on line 3, you will see that, that the number of kgs each sack can hold is 20 kgs. Okay, so and what we want to tell the user is, in order to pack 800 kgs of rice, okay, so in order to, on line 12, if the total amount of rice that needs to be packed is 800 kgs, and each sack can hold 20 kgs, then the number of sacks required is 800 by 20, which is 40 sacks. And that's what we are doing here. On line 9 and line 10, on line 9, we are asking the user, could you please let me know how much quantity of rice that needs to be packed? And on line 10, we are reading that the weight of the rice that needs to be packed. On line 12, we are computing the amount of the number of sacks required. And on line 14, we are printing the output. One new feature that that is being introduced now is there is this idea called as macro. So on line 3, we are declaring a macro, or we are defining a macro called as kgs per sack. So this is what is called as a macro definition. And so on line 12, what happens is these kgs per sac at compilation time itself, it will be replaced with 20. This is what your CPP program does. If you recall, CPP is C preprocessor program, and GCC first calls CPP before it compiles the program. So what happens is initially all these hash defined directives, hash include directives will be taken care of by the C preprocessor. As a part of that, this kgs per sac variable, it will be replaced with 20.
Excuse me, sir.
Yeah.
So what is the benefit of defining the variable in the preprocessor, right, rather than just using like int kgs per sac equal to 20?
Good question. In this particular case, one thing is you can keep all these meta information separately from the program. So that is one advantage that I see. In terms of performance, I don't see any difference actually. Good question. But right now, it's very clear that kgs per sac, it is not, no, it is not part of this code, and it is written separately. And so, yeah, if it's a variable, the value of the variable can change, etc. But this kgs per sac, it's not going to change. It's going to remain constant. 20.
So
Yeah.
So if I suppose I define a global variable in the form of kg per sac, is it the same thing?
You can do it, it will still work, but a global variable can still be changed by some program. Some program statement can change the global variable knowingly or unknowingly, but when you do this, it's not going to change. Yes, macro is different from global constant variable.
Can't we use static?
Sorry?
Can't we use a static global variable instead
No,
of that?
static global variable, it's not going to help you. There is something called as a constant qualifier you can keep in order to make that happen, but static is not going to help.
Okay.
So there is this question, there is return 0 missing. Even if you don't put return 0, the program will still work. So we don't need to worry, okay? The compiler automatically inserts it. It knows that this is the main function. So at the end of the main function, some return should be there. So it will, even if there is no return at the end of the main, it is still okay. So there are a bunch of questions on macros. You will understand those questions or different approaches instead of using macros. I think we have to weigh in those options, understand the trade-offs. But for the time being, all I want you to know is whether you understand this macro or not. What this does is wherever kgs per sac is there, it will be replaced by 20. That is its definition. This much, are you with me?
Sir, so if I were to put kgs per sac inside the printf statement, would I get 20 when I print it? Or?
Yeah, you'll get it. Yeah.
Okay.
So what's the difference between defining kgs per sac outside and inside the main function?
We can declare it, but usually all the macros we want to define at the beginning of the program.
Sir.
Yes.
Sir, so can we define keywords as macros? Like if I say define show as printf.
Can you define show as printf? It is possible. So wherever show is there, printf will be replaced.
Oh, okay.
Yeah.
Thank you, sir.
Good question. So write out.
So is my voice audible?
Yes, yes.
Sir, so if we say, for example, do cpp rise.c and try to view its pre-processing file,
yeah.
So will the kgs per sac be replaced by 20 everywhere in the program?
Yeah, let's see. So there are questions. See, you have naturally nice questions. So we should take things slowly. All your questions they will be answered as we keep progressing. All I want you to know at this point of time is we are defining a macro called as kgs per sac, and wherever kgs per sac is there, it will be replaced with 20.
But if
sir?
print kgs per sack, will I need the %d or I can just write kgs per
No,
sack?
no, you have to use %d.
Okay, sir.
Printf %d kgs per sack. So let's see this question. So CPP cube2.c greater than cube2.i. Okay, so let's open this here. So this is the file that is obtained after yeah. If you go see here cube2, oh sorry, this is RICE. Sorry guys, we compiled the wrong program. RICE.i, Control O. Yeah, if you see RICE dot, look at line 805. So if you see line 805, that kgs per sack is replaced by 20. And then that hash defined kgs per sack is no longer present in this file because it is already being processed. Are you happy now? Yes, Anirudh, if you can define hash define p printf, and so what you are suggesting can work, but it's all risky things. Okay. So now let's go and see.
So, sir, I had a doubt.
Yeah.
Sir, I just tried the code. Like, I just wrote a very small one that was like, I just declared a variable m and assigned the value 2 to it.
Mm-hmm.
And then I used a printf statement for print a %m.
Okay.
That's all. And then I executed the file and it just printed success. That's all. Why?
I will take your question later. Okay. After the
Okay,
class, maybe I'll look at the code and see what's the issue.
Okay, sir.
Okay.
Thank you, sir.
All right, guys. So I think we should keep moving. So let's run this program and see what happens. GCC price.c. So remember, I didn't use any -o. Maybe I will use -o. So enter the quantity of rice, 800, and the number of sacks required for to fill in 800 kgs of rice is 40.
Sir, one question.
Yes.
You previously said that when you use hash define, right, you assigned a certain value to kgs per sack.
Okay.
So now in the program you said printf you'll need %d, kgs per sack, right? But then how will you know? How will the system know what the data type of kgs per sack is?
No, what is it? Can you repeat again?
I'm saying that if you've already defined kgs per sack earlier before you wrote the main function.
Yeah, that's true.
And then you're using, and then for printf, if you're using, if suppose you want to use printf kgs per sack, you'll have to use printf %d and kgs per sack after that, right?
True.
How will the system know what the data type of that is? How will you know which this thing to use?
No, but you know, right? 20 is an integer, so you have to use the appropriate modifier, right?
Okay.
Because you know it and you have to use it. The system wouldn't know.
Oh, okay. So that just depends on what you want to use at the time.
Yeah, that's true. So let's say now, if you want to pack 850 kgs of rice, so yeah, so if you want to pack, let's instead of 850, let's say you want to pack 801 kgs of rice. So if you want to pack 801 kgs of rice, then the system still says that it is you only require 40 sacks. But whereas you require 41 sacks, agreed that the last sack is not completely full, but you still require 41 sacks. So this is the problem. So because since we are working with integers, so what happens is in the case of when we are working the division operation in C with respect to integers, it is kind of bit weird. So 3 over 2, it is 1.5, right? So what it will do is it will, it kind of ignores, truncates the fractional part, and the result that comes out will be 1. It doesn't round the value, it ignores the fractional part. Right? So similarly, let's say, so if you have 9 by 3.1, then you know the value that comes out will be 2. No, it's not, 3.1 is not an integer. Okay, so yeah, so 9 by 3 is all right, but let's say 9 by 4 if you take. If you take 9 by 4, then what happens is, you know, 9 by 4 is 2 point something, you know, this is equal to 2 point something, but the value that turns out to be will be 2. So how do we solve this problem? So we want to know the exact number of sacks. So that is, if you require 40.1 sacks, then we should give 41 sacks as the input. And one way to take care of this is by using a function called as the ceil function. There's a library function called as ceil. So we'll use ceil. And if you hover over this, you know, ceil will return an integer. You can see that the signature for ceil, that ceil returns an integer. And ceil, in order to use the ceil library function, you have to include a new .h file, that is math.h. So let's see if this works. So let's still use 801. So even after using ceil, it is still saying that the number of bags that is required is 40 sacks are required. The reason is, if you see the parameter that is being passed to ceil, it is already an integer. So let's say here you have, you know, what is, so you have 801 divided by 20. But before it is being passed as a parameter to the ceil function, it is already rounded to 40. Because of that, ceil is being useless. No, I compiled it. There's a question whether I compiled it, but if you have that doubt, I will do it again. But what I want you to appreciate before I go there is the value that is being provided to ceil, it is already truncated.
Sir?
Just 1 minute. So those of you who have a doubt, GCC rise rise. Yeah. So you see, it's not 41 sacks, it is 40 sacks. So what is the question?
Sir, I was asking what exactly does ceil do?
So what ceil does is, if ceil takes a decimal number like 40.2 or like, for example, ceil is a function. So if you give ceil 4.2, it outputs 4. So any value, if it is 4 plus some epsilon, it gives a 4 as output. That's what ceil does.
Sir, but
and there is an opposite function for this, that is floor. If you use floor 4.2, it gives, oh sorry, this should give
5, first
5,
one.
sorry.
Okay, understood, sir.
So this will give 5, this floor function will give 4.
Yes, sir.
So, but what we have to do is, we have to give, in order to make this whole expression, in order to, weight is an integer, kgs per sack is an integer. So we want to get over this block. So what we will do is this. Clear. So here we will make kgs per sack as a floating point number. Okay, 20.0. So when you divide an integer by a floating point number, then what happens is the integer will also be turned into a floating point number, and the result will come into a decimal number. So now let's try to compile this program and see what happens. So now you can see it is complaining that you are using ceil, but ceil is an undefined function. So ceil is present in a special library called as math library. In order to use the ceil function, we have to use -lm option, which means link math. So GCC rise.c -lm, I want you to pay attention to this -lm option. That is link math. And .a.out. And now let's see 801. It should be 41, right?
So 1 second, sir. Why didn't you use -lm the last time then?
Sir,
Sorry,
using a.out, sir.
I think I entered the wrong command. I'll answer your question. So 801. Yeah, now we get 40. So here, those of you who are paying attention, I compiled the executable to rise, but I ended up executing some other a.out before. So because of that, I got the wrong output. But once I execute the rise, and if I give 801 cages, then we get 41 as the number of sacks required. So the question is why -lm flag? So when we are using math functions, when we are using functions which are declared in the math.h file like ceil, floor, etc., we have to explicitly link it to what is called as a math library by using the -lm option. Link math, it stands for link math.
Yeah, sir. But then in the previous time you executed it without making kgs per sac as a float number, that time also you were using ceil, right? So why did it give you an error at that time?
Oh, is it?
Yeah, you used ceil then and showed us even with ceil, it only gives you 40, right?
That is because sir executed a.out, not the.
Oh, yeah, I think, but the compilation error should have been there, no?
Yeah, the compilation error will still be there, right? Because you didn't link math there then. So you can try. Can you try it again? Like take the float out. And...
Very good question. Let's see what happens. Okay, I have a suspicion what is happening. So very good question.
Maybe you can save it.
Yeah, GCC. Yeah, it's not complaining, but let's say I know what is happening actually.
So is it because the ceil doesn't function anyway?
But here it is. See, what is happening is when we are using 20 here, I think compiler is recognizing that the parameter that is being passed to ceil is an integer and it doesn't require ceil in any case. So it is dropping the ceil. So, but otherwise, if ceil is actually being used, then it needs to be passed as then we have to link it with the math.
Okay, sir. Thank you, sir.
But does it actually happen?
An excellent question, man.
So why don't we try with 20.0?
Yeah, we tried it now. Let's try it with 20.0. There is a problem. Very good observation. So now when we link it with math, it works. The default is not -O0, Kishore. I think it is -O2 or -O1. It's not O0. So some of you guys may be lost here, but don't worry. All I want you to appreciate here is this. So by making this kgs per sac 20.0, we are forcing this computation to be a fractional computation, like a weight is integer, but that's all right. And kgs per sac is a floating point number. When you divide an integer with a floating point number, the resulting type will be float. And we want to round it off, not round it off, we want to ceil it. And in order to ceil it, we are using the ceil library function. And in order to use the ceil library function, we have to include math.h. Not only we have to include math.h, we have to use -link math option. Are you with me here till this point at least?
Sir, so in that case where you use 20 and not 20.0, if you don't include math.h also, still compilation will happen successfully?
Yes, yes.
Okay, sir.
That seems to be the case. That's what is happened.
Can you try it once, sir?
We tried
Without
it once
math
already. So
No, sir, without math at all.
no, without math we tried now with this. Which one with
Not
now this
LM,
is
sir.
complaining.
Include math.
Sorry.
He means in the code, sir.
In the code, what should I do?
Remove include math.h.
Oh, remove include math.h. Okay. Let's see what happens.
You know, without LM.
No, even without LM, it doesn't matter. It's not even going through the compilation process. You can see it is giving that its seal is a problem with seal.
So without 20.0, just
Sorry?
20. Just 20, 0
Oh,
20.0.
okay.
Will it call the seal function or not?
See, this happens before actually all this optimization happens. That seal, the compiler does what is called as a semantic analysis. So the compiler, the first part of the compiler sees that everything is in place. So when you use seal initially, there is a component of compiler which tries to look for, hey, what is this seal which this user is using? So let's say if seal is there, if it knows what seal is there because hash include math.h is there, so it will get on with its job, but later an optimizer component comes and drops the seal. Does it make sense?
Yes.
No, sir. Can you explain again?
See, what is happening is, let's say if this is there, okay, you have include math.h. Okay, and by including math.h, you know what seal is. Okay, the compiler knows what seal is. But this is the front end. There is what is called as a front end of the compiler, and there is a rest of the compiler. The rest of the compiler, what it does is, if the optimizer component of the compiler sees that seal is all the time being passed an integer, so it just drops the seal altogether. So we don't even need to link with. So the necessity for linking with the math library is not there. But what happens when you comment this? The front end of the compiler tries to understand what seal is, okay, but it's not there, so it complains. That's all it is. So I think let's not get into this too much. Maybe we will revisit it at a different point of time.
Sir.
Yeah.
Sir, we have to include that in terminal minus LM, and also we have to include math.h. We have to do both.
Yeah, that's true. In the source code, you have to include math.h, because by including in the source code what math.h is, you will tell the compiler what seal is. Okay. And then later on, you have to use math minus LM also in order to link with the actual math library. Okay. So this is the final version of the code. And let me use 801. And if you do 800 and what is happening now?
20.0.
Data type is an integer form, not float.
Thanks, yes, you are confusing me wonderfully. $800, great. 801.
Sir, you've.
Sir, you're using A.out.
Sorry. Brilliant. Thank you. So wait. Yes. Good. So this is how it works. Okay. So there is one thing that I want you to keep in mind. Maybe we will pick up that idea later. But are you all with me on this code? I think we spent sufficient time and many nice ideas came out from the discussion on this code.
Yes, sir.
So why didn't we use return 0 in this one?
See, return 0, it's a good practice. Even if you don't put return 0 also, the program will still work. It is implicitly included. The compiler, if you don't put it, compiler automatically inserts a return, some return statement there.
Sir, if we do not write minus, sir?
Yeah.
Sir, if we do not write in terminal minus o.tries, just minus lm,
yeah,
then it will compile the file in the form of a.out.
Yeah, that's true. That's true.
Sir, I have a doubt.
Yeah.
Sir, this is Amay. Up till now,
I lost your voice, Amay.
yes, sorry, sir. Am I audible now?
Yeah.
So, sir, if we use 815 kilograms of rice,
Okay.
so it will just give us 41 and it will be done with it because he'll will round it up to 41 and that's all.
Yeah, that's true.
But what if I define another kind of sack? So the first sack can take 20 kgs of rice. Now I want to add another variable that this is a smaller sack. It can hold 5 kgs of rice.
Okay.
So what I want is once all the 20 kilogram rices are filled, the sacks of 20 kg rice are filled. I want the remainder of the rice to be filled in 5 kg sacks.
Okay.
So in that case, how will we utilize seal function? Because it's just rounding it up. It's not giving that, hey, it's up till 800, you can fill it in 20 kg sacks. And the remaining 15 kg can be filled in 3 5 kg sacks. How would I get that?
Okay, good question, Ame. So it's a homework problem. So there is one homework problem today which is along the same lines. Do you think about it? All right. Good question, Ame. Valid question. So, but you will get an answer to it through a homework problem that you are going to solve.
Sir?
Yeah.
Sir, what was the thing with 20.0 and 20? I did not understand that.
See, what happens is this much. Yeah, this is a good question. I want everyone to understand this. See, weight is an integer. Okay, so this is an integer. This is of type integer. And there are two cases we considered. Let's say the weight is 800. Okay, or let's say for the sake of simplicity, the weight, yeah, let's say the weight is 800 and there are two cases, or 801. Or let's say, yeah, let's say 800. So there are two cases. In one case, we are defining kgs per sack as 20. It is an integer. And in another case, we are defining the weight as 20.0. So in C, when we divide an integer by an integer, we get an integer. Okay, this is so 40 sacks. But here, when you divide 800 by 20.0, this is an integer and this is a float variable, decimal number. So you get 40.0 as the answer. So if one is a float and another one is an integer and another is a float, then you get something like this. So similarly, let's consider the case where it is 801 and this is again 20 and this is 20.2. And then so here you divide 801 divided by 20. So when we divide two integers, then what happens is the decimal point gets truncated. But here, when one is a, yeah, so when one is an integer and other is a decimal number, then what you get is 40 point some decimal value you will get. Does it make sense now? Are you all with me on this one, this particular idea?
Sir?
Yeah.
Yes, sir.
Sir, if we do number of sacks, set number of sacks to float value, then will it give the 800 divided by 20, 801 divided by 20 a float value?
What is that?
Sir, we have set number of sacks to an integer.
Yeah,
value.
that's true.
If we set it to float number of sacks, then if we divide 801 by 20, will it give 40.0?
Yeah, that's true. Yeah. Okay.
So,
yeah.
So if we don't use -o, or if we don't create a flag and we just implement a.out, then why won't we get answer as 41?
What is it?
Yes.
Can you repeat again?
So if we don't create another, like we don't use -o, okay,
Yeah.
we just do gcc -lm and the function.c, name.c.
Yeah.
Then why don't we get answer as 41 with a.out?
No, because see, it will come. See, if you just no, are you seeing the screen?
Yes.
So here we are creating the executable in RICE. So because of that, if I use a.out, it's an old a.out. Because of that, it's not working. But if I just don't give this, then instead of generating the executable in RISE, it gets generated in a.out. And if I see a.out, what happens? Now it will still work. It is working.
Oh, okay, sir. Got it. Thanks.
Okay, so I will take 5 more minutes before you all break for the lab, and I will tell what you will be doing in the lab, but just give me 5 minutes. Yeah. So this is about few things. Yeah. So the macro names, the variable names that we are using, the variable names that you are using, the variable names like length, breadth, and height, function names like main or some other function names, and macros like kgs per second, all these things, these are called as identifiers. And they are rules which we have to follow in while creating, while giving names to these identifiers. So every identifier, it should start with a letter or underscore. And it can contains letters, digits, underscores. These are the things an identifier can contain. It can contain letters, it can contain digits, it can contain underscore. And an identifier can start with a letter or it can start with a underscore symbol. But it is best that you should avoid naming identifiers with underscore, because many times we start an identifier with underscore if it is a special purpose system variable. So don't try to use variables whose names start with underscore. And if you see here, these are two identifiers cannot start with letters. Like for example, this identifier is starting with a letter, it's an illegal identifier. And in this identifier, there is a dash symbol or hyphen symbol, and so that's the reason it's an illegal identifier. Underscore is possible. Underscore is possible, but not dash. So these are the rules for forming identifiers. Next is the identifiers in C, they are case sensitive. That is, like for example, here you can see that this is job where all the letters are small letters, but this identifier is different from this identifier because B is used in a caps form here, but it is used as a small letter in the first identifier. And this is different from this because we have a small O here, but we have a big O here. And this is a small b, and this is a big B, and this is a small, so on and so forth. So identifiers are case sensitive. And so when you want to have identifiers with meaningful names, when you want to have identifiers with meaningful names, then like for example, symbol table or current page, you may want to use, there are two notations people use. One is underscore, symbol underscore table, but there is an alternate convention which is called as camel case, where the first letter will be small, the first word will be small, but all subsequent words within the identifier, they will start with a capital letter. Table, it starts with capital T. And this is a current page, current, the first word is small, this is capital. This is what is called as a camel case. And there is no limit on the maximum length of an identifier. Remember this is underscore. Underscore is different from dash or hyphen. So this is wrong. Symbol table, this is wrong. You are not allowed to use this. The next idea. There is one important idea here. Chapter 2. Okay, then I will stop here actually. There is one idea that I wanted to discuss, but it is not here. So, but we will take it up in tomorrow's class. That should be all right. So with this, I will conclude today's lecture, and I'll also stop the recording of the class.
So I have a question. So what is this? I have noticed in the code that we use this after, right, in this code that is present there. We after printf we used it semicolon. Why do we use it? What is the use of this semicolon?
So that is what we will see in tomorrow's class. That's what I was I thought I will explain.